So today we're going to look at something called the distributive property. And this is going to be on page 13 of our journal. Page 13. Alright, so this is the handout the class is getting. Of course, you're welcome to print it out if you would like to, but if not, that's perfectly fine. We're going to write it anyways. Alright, so we're going to put at the top of this, distributive property. And we are going to put baby. Okay. So we're going to start by, and we are going to write it pretty big. I'm going to use 3 lines or 2.5. I don't know, I write pretty big. So B parentheses A plus Y equals B A plus B Y. And under the BA, we're going to put that this is multiplying. Multiply. And we're going to talk about how to use the distributive property. Alright, so using the distributive property. So the example they give is 4 times 36, which is the same as doing 4 times 30 plus 6. Which means that I can distribute. So I'm going to literally give that 4 to my 30. So I'm going to do 4 times 30, that's my B times my A, plus, because there was a plus between these, it might be hard to see because I'm writing in pencil, plus, give my 4 to my 6. So 4 times 6. And we could solve it from there. Alright? So this may seem a little weird at first, but the more we do it, the better we'll be at it. And we're actually going to be doing it with variables. This is something they teach, a way they teach it to some younger grades when they're talking about expanding numbers or teaching different ways to multiply. We are not going to do that. We're not going to do it with regular numbers. So slide to the left of page 13. Alright, and we're going to practice some examples. So on this side, we're going to have examples. Oh, sorry, trying to get it adjusted. Alright, so let's say that I have 3 parentheses x plus 5. So I'm going to take my 3 times my x, and we're going to write that as 3x. Bring my plus, whatever sign I used there, 3 times 5. 3 times 5 is 15. Now we can see that this is true if I plug in a number. So let's plug in 1 here for my x. So 1 plus 5 is 6. 6 times 3 is 18. 3 times 1 is 3, plus 15 is also 18. So we can see that they are truly equal. If I plug in any number, it's going to be true. So let's look at another example. And it doesn't always have to be x. I'll change the variable on the next one. So we're going to give that 4 to the x, and we're going to multiply it. Because this right here, a parenthesis, so when I have a number next to a parenthesis, that means multiplication. Sorry, I got pen all over me, and that's why my hands look so messed up. Sorry, so 4 times x is 4x. My plus, because I have a plus here, 4 times 2 is 8. So let's look at it when it's a little bit different. So how about 3, and we'll do 2m plus 1. So I'm going to do 3 times 2m. So a good way to think of this is if I'm looking at maybe some objects, okay? So I have 2m, so I'm going to say 2 writing utensils. So there's 2 writing utensils. Here's 2 writing utensils. Here's 2 writing utensils. Okay? So if I have 3 groups, because there's 3 groups of 2m, and I combine them, I have 6m. 1, 2, 3, 4, 5, 6. So 3 times 2m is 6m. Used in addition. 3 times 1 is 3. Now, a common mistake people do is they don't give that 3 to both numbers. I've also seen when people have added instead of multiplied. Just remember this parenthesis means multiplication. It's not always done with addition. Sometimes we have, let's do 7, and we'll do r minus 3. So 7 times r is 7r. Bring my subtraction. 7 times 3 is 21. We can also have what's called a coefficient in front of that r. So let's do 5, but let's do a different variable. Let's do j. Let's do 3j's minus 5. 5 times 3j is 15j. 5 times 5 is 25, and the problem was subtraction. All right, so let's look at a little bit different situation. So let's look at, I'm going to try to show as many different weird situations as I can. Let's do Let's do 8 minus 2p. Okay, same exact thing. I'm going to distribute that 6 to the 8. So 6 times 8 is 48. Bring my subtraction. 6 times 2p is 12p. So it doesn't always have to have my variable first. Sometimes my variable can be the second one. All right. We should still have a couple lines left on your page, so we're going to look at some other examples. So let's try a negative out front. And I know negatives scare us, and that's okay. Let's do negative 10. And we'll do 7 plus, we'll start with addition, plus 3p. So I'm going to give that negative 10 times my 7, which is negative 70. Addition, negative times 3p is negative 30p. So even if there's a negative attached to it, I bring that negative with me. All right, let's look at another negative examples, because sometimes we have some tricky negative examples. I'm going to show you one. Sorry, I'm having pencil issues. Negative 4, and let's do 3d minus 5. So I'm going to do negative 4 times 3d. So negative 4 times 3 is negative 12. Bring my d with me. I have subtraction. So something, when we're having a negative and a subtraction, it's sometimes very helpful to go ahead and add a line, change a sign. Now I'll do it without the add a line, change a sign and show you what you're going to do. So you have a subtraction. And then negative 4 times 5 is negative 20. But if I go ahead and add a line, change a sign, so I'm going to go ahead and do that. I'll do it lightly so you can kind of make sure it can still be kind of seen in the video. Add a line, change sign. Some of you who went to other districts might have used keep, change, change, or keep, flip, change. Those are some different ones, but if you went to New Waverly schools so far, we've taught you add-a-line change a sign. If you go to Huntsville schools, they also, as far as I've known, have always done the add-a-line change sign also. I would have an addition, so I'd have negative 4 times 3d, which is negative 12d, plus negative 4 times negative 5, which is positive 20. And the reason, even though these look different, is when I add a line change a sign here, it makes the same problem. Negative 12d plus 20, negative 12d plus positive 20. Same thing. I tend to go ahead, when I know I have a negative, to go ahead and add a line change a sign, just to keep it as an addition. It seems to work a little bit better for people that way. So one other example that's kind of a tricky one, and it's also a negative one, is this. 5e minus 3. Sorry, that's my phone buzzing. So in this case, and we will look at some more like this, there's nothing here. It's just negative. So you could think of, I'm going to give the negative to everything, but I found in many years of teaching that it's easier if students realize there is an imaginary 1 there. So I'm going to go ahead and put the 1 there lightly. Okay. So now I have negative 1 times 5e, which is negative 5e. I have a negative and a subtraction, so I'm going to go ahead and add a line change a sign. Negative 1 times negative 3 is a positive 3. All right. Pretty much if you times a negative 1, it flips everything in here. So this is now a negative. This is positive. This is going to be negative also. Positive also. So it became a negative, it became a plus, and it became a positive. It flipped everything in it to its different sign. We will be practicing more of those because we're going to be using those. This is a huge concept that you'll need for next year, so please be sure you're getting it down. We are going to be using it over the next week or so as we work on solving some harder variable problems. It does get a lot more challenging, so please make sure you're staying up to date on it. You have a journal test on Monday. Please get caught. Some of you might have noticed, I don't know if you paid attention, but I've already deleted the first half of the journal pages, so hopefully you've been taking care of it. All right, that's all I got for you. If you have questions, you now have to email me or send them through, you can't send them through chat anymore. They've blocked that for now. All right.